Hi, my name is Basir. In this video, we'll go through Chapter 8, Similar Triangles from Class 10, Andhra Pradesh and Telangana State Board Syllabus. So what is a similar figure? Geometrical figures which have the same shape but not the same size are called similar figures. Let me give you some examples of similar figures here. Here you have in the first picture you have similar squares, and here in the second picture you have similar equilateral triangles and then you have here similar circles. So the square that you see here inside, this square and this square, they have the same shape, the square shape, but the sizes are different. Such figures are known as similar figures. So geometrical figures which have the same shape but not the same size are known as similar figures. Now these squares that you see here, the angles, each angle in a square is 90 degree, right? Each angle in a square is 90 degree, and all the sides of a square are equal. Such a polygon is also known as a regular polygon. A polygon in which all sides and angles are equal is called a regular polygon. So this equilateral triangle that you see here, this is also a regular polygon, because in an equilateral triangle all the sides are equal plus all the angles are also equal. Each angle in an equilateral triangle is 60 degrees. 60 plus 60 plus 60 makes 180. Right. This is my original picture here. That's my original picture here, the first one. This picture that you have, this picture and this picture, do they look similar? No, they don't look similar anymore, because this picture, the second picture, it looks distorted because I have stretched this picture lengthwise along the length. I have stretched this picture, keeping the breadth same. You can see here the breadth of the original picture and the breadth of the second picture are same, but I have stretched the second picture, keeping the breadth same. I have stretched the length, only the length. So this picture that I have now got, this picture looks distorted. It does not look similar to the first picture, the original picture. See this third picture here. In the third picture you can see that the length of the original picture and the length of the third picture are same. So this time what I did is I kept the length same, but I stretched it along the breadth. I have stretched this picture. So this picture and the original picture, they do not look similar anymore. They do not look similar anymore, because I have kept the breadth, I have kept the length same, but I have stretched the breadth. So this picture is also distorted. But look at this picture, the fourth picture. The fourth picture, I have stretched it proportionately. So I have increased the length also. See here, the length was this much for the original picture, but this fourth picture has a pretty big length. Breadth also, compared to the original picture, the breadth also is increased. So I have increased the length and the breadth, both the length and the breadth this time. So this picture, the fourth picture that you see out here, has been stretched proportionately. So it does not look distorted. It is similar to the original picture. Two polygons with the same number of sides are similar if the corresponding angles are equal. And the second condition is corresponding sides are in the same ratio. So two polygons are similar if the corresponding angles are equal and the corresponding sides are in the same ratio. Let's say that I have two triangles here, triangle ABC, and then I have another triangle DEF. Obviously, by looking itself, you can tell me that the size of triangle ABC and the size of triangle DEF is not same. Triangle DEF is bigger than triangle ABC. But it looks like both of them have the same shape. They look similar. And when will the two triangles have the same shape? They'll have the same shape only if the corresponding angles are equal and the corresponding sides are in the same ratio. So angle A, let's say the angle A is equal to angle D, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. So if the corresponding angles are equal and if the corresponding sides are in the same ratio, let's say AB and DE are the corresponding sides, so the ratio would be DE by AB. Let's say DF and AC are the corresponding sides, so the ratio of DF and AC would be DF by AC, EF by BC. Now let's say let us say the side here is 2. Let us say this one is 3 and this one is 5. Let's say this is 4, this is 6 and this is 10. Then what would be the ratio here? The ratio of sides would be DE is 4 by AB is 2, DF is 10 by AC 5, EF is 6, BC is 3. So we see here that the ratio is same, 2, 2, 2. The ratio is 2. This 2 is known as the scale factor. This 2 is known as the scale factor. When two triangles are similar, let's say triangle ABC is similar to triangle DEF, symbolically we represent it like this. Triangle ABC is similar to triangle DEF. This symbol is read as is similar to. So how do we read this thing here? Triangle ABC is similar to triangle DEF. You must have seen a ruled paper. Let us try to draw a triangle on a ruled paper just like this. So I have drawn BC on one of the lines here, and then I have formed a triangle ABC. I have taken 2 points on the other line, this line. I have taken 2 points on the other rule, P and Q, and I've joined the points P and Q. This line PQ is parallel to BC, obviously, because all the rules here that you see, all the rules or the lines on this ruled paper, all those lines would be parallel to each other, right? So this line PQ is parallel to BC. When you find out the ratio of AP and PB, AQ and QC, you will observe that AP by PB is equal to AQ by QC. This result is known as basic proportionality theorem. So basic proportionality theorem states that in a triangle, let's say you have a triangle, if you have a line parallel to one side of a triangle, then that line will divide the other two sides. The other two sides are AB and AC here. It will divide the other two sides in the same ratio. That's the result of basic proportionality theorem. Let us try to prove the basic proportionality theorem now. That's the statement of the basic proportionality theorem. The basic proportionality theorem says if you have drawn a line parallel to one side of a triangle, so this is my triangle ABC. I have drawn a line DE parallel to the side BC. So if you draw a line parallel to one side of a triangle to intersect the other two sides in distinct points, so distinct means different. So this line DE is intersecting AB and AC, the other two sides, in two different points D and E. Then the sides are divided in the same ratio. Then these two sides AB and AC, they are divided in the same ratio, which means we have to prove that AD by DB is equal to AE by EC. So required to prove what do we have to prove? AD by DB is equal to AE by EC. So that is something that we have to prove. I'm not going to write the complete proof. I am, however, going to explain it to you, the proof itself. What we need to do is we will first go ahead and draw a perpendicular EN perpendicular to the side AB. So EN is perpendicular to the side AB, and we'll draw another perpendicular DM which is perpendicular to AC. DM is perpendicular to AC. Now we have to prove that AD by DB is equal to AE by EC. AD, if we consider AD here, AD, it's making a triangle here. AD, this one is, we'll consider this triangle here, triangle ADE, which includes AD. So I have to prove that AD by DB is equal to AE by EC, right? So I'll take a triangle in which AD is a part of that triangle. So AD is a part of this triangle ADE. And what is, let us consider triangle ADE. And what is area of a triangle? Area of a triangle is half base into height. What is the base of this triangle ADE? The base is AD, and the height is EN, because EN is the perpendicular, right? So EN is my perpendicular height. Next, let me consider DB. DB, it is forming this triangle, right? BDE. DB, my side DB here, is part of this triangle BDE. So let me consider triangle BDE. Consider triangle BDE. Again, area of a triangle is half base into height. Half base. What is the base here? BD. And what is the height? The perpendicular height for this side is EN, right? So I'll take the height as EN. Now let us consider triangle ADE, area of triangle ADE by area of triangle BDE. Here the area is half AD into EN, half AD into EN, by area of triangle BDE is half BD into EN. This EN and this EN gets cancelled, half and half gets cancelled. So what would be triangle area of triangle ADE by area of triangle BDE? It will be AD by BD. AD by BD. Okay. Now that this is done, let me take the right hand side AE. AE is part of this triangle ADE. So I'll consider triangle ADE. Triangle ADE, area of triangle ADE again should be half base into height. Base, I'm taking AE. Perpendicular height for AE is what? DM. So half base into height. Base is AE and height is DM. Next, I will consider triangle. What is the side that we have here? EC. EC. EC is forming this triangle here, DEC. So the side EC is part of this triangle DEC. So I'll consider triangle DEC. Again, the area should be half base into height. Base is EC itself, and height for this side, EC is again part of this bigger side, right? And for this side AC, what is the perpendicular height? It is DM. So base is EC here, and what is the height here? DM. DN. Sorry, DM. My bad. It is DM. DM. Okay. Now again, I'll consider area of triangle ADE by area of triangle DEC. What do I get if I divide ADE by DEC? Half gets cancelled, DM gets cancelled. I will obviously end up getting AE by EC. So we have already proved these two things here. The first one and the second one. For lack of space, I just erased everything and I wrote this thing down here. Now if you consider this triangle DEC and the triangle DEB, you see that the triangle DEC and the triangle DEB, they lie between the same parallel lines DE and BC, and they are on the same base. So for this triangle DEC, the base is DE, and for the triangle DEB also the base is DE. So these two triangles DEC and DEB, they lie between the same parallel lines and they lie on the same base. Such area of such triangles will always be equal. So area of triangle DEC, area of triangle DEC will obviously be equal to area of triangle DEB. Why? Because they lie between the same parallel lines and they lie on the same base and between the same parallel lines. So that the area of DEC and DEB should be equal. DEB, I can write it as DBE also. Let me just write it as DBE, this one. Instead of writing it as DEB, I can write it as DBE also, or BDE also, BDE. Now what do you see? Let's say this is my first equation, this is my second equation, and this was my third equation. What do you see here? If you see the first two equations, the numerator here is ADE, triangle ADE, triangle ADE. The denominators were different, BDE and DEC, the denominators were different, but now those denominators are equal, right? Triangle DEC is equal to triangle BDE. So DEC is equal to triangle BDE. Both the denominators are equal. Numerators were already equal. Now the denominators are also equal from the third equation, which means the left hand side of these two equations is equal. If the left hand side is equal, I can the right hand side will also be equal. So obviously AD by BD will be equal to AE by EC. That is what we wanted to prove, right? AD by DB is equal to AE by EC. So this is basic proportionality theorem, which is also known as Thales theorem. And we see that in a triangle, if we draw a line parallel to one side of a triangle, it will intersect the other two sides in the same ratio. Let us now go through converse of basic proportionality theorem. Let us go through converse of, in short form it is also known as BPT. Popularly it is known as BPT theorem, basic proportionality theorem. We'll now look at converse of BPT. Converse of BPT would obviously say the reverse of it. It would say that if two sides are divided in the same ratio, then the line would be parallel to the third side. That's the converse of BPT. Let us prove converse of BPT here. Let us say I have a triangle here, triangle ABC. I have a line DE, and this line is cutting the two sides AB and this side AB and AC in the same ratio. It is cutting AB and AC in the same ratio. When it is cutting AB and AC in the same ratio, it means that AD by DB is equal to AE by EC, right? AD by DB is equal to AE by EC. So this is given. We have to prove that DE is parallel to BC. We have to prove that DE is parallel to BC. I'll just erase everything else here so that I can make some space to prove converse of BPT. So this side DE is intersecting the other two sides AB and BC in the same ratio, which means AD by DB should be equal to AE by EC. We have to prove that DE is parallel to BC. How do we prove DE is parallel to BC? Let us say DE is not parallel to BC. Then there should be some other line DE dash which should be parallel to BC, right? Let's say DE is not parallel to BC. We will prove this by using contradiction. So what we do is, we will assume that DE is not parallel to BC. If DE is not parallel to BC, then there should be some other line DE dash which should be parallel to BC. If DE dash is parallel to BC, then obviously AD by DB will be equal to AE dash by E dash C by Bpd theorem, right? The ratio of the ratio of sides should be equal, right? So AD by DB should be equal to AE dash by E dash C by basic proportionality theorem. So what we do here, if we prove this by contradiction, we'll say that, okay, if DE is not parallel to BC, then there should be some other line DE dash which should be parallel to BC. If DE dash is parallel to BC, then obviously the ratio of sides should be equal. AD by DB should be equal to AE dash by E dash C. If this is my first equation and this is my second equation, what do we observe from both the equations? We observe that the left hand side is equal. AD by DB, AD by DB, the left hand side is equal. So from 1 and 2, if the left hand side is equal, I can equate the right hand side. AE by EC should be equal to AE dash by E dash C. Now let us apply componendo to this. Componendo means you just have to add 1 to both the sides. Left hand side I am adding 1, and similarly on the right hand side I am adding 1. What really happens now? AE plus EC into 1 is EC. I'm just cross multiplying it, or else taking the LCM of it. EC dash into 1 is EC dash, E dash C by E dash C. What does this become? AE plus EC. AE, let me plug the charger. So this obviously becomes, what is AE plus EC? AE plus EC is nothing but AC. So it becomes AC by EC, and this thing becomes AE dash, here AE dash plus E dash C is nothing but AC. AC again, AC by E dash C. What really happens here? AC and AC, they get cancelled, and obviously if I just cross multiply, I now have AC and AC gets cancelled, so I now have 1 by EC is equal to 1 by E dash C. If I cross multiply, I'll get E dash C is equal to EC. So when is E dash C equal to EC? It is possible only when E dash and C are only one point and not two different points. So this is possible only when E dash coincide with E, which means DE itself is the line which is parallel to BC. Hence proved. The rest of the videos of this chapter will soon be available on our website, which is basiracademy.com. And I believe the best way to get help from me is by logging on to basiracademy.com website and using the live chat feature. You can always use the live chat feature and ask for help, and I'll be readily available to help you out. Thanks for watching. I'll see you all in the next video. Have a very nice day. Goodbye.